Welcome to the IN2 video lecture. This is going to be covering the properties of rational exponents, part 1. Here, I want you to understand the rational exponent. The two success criteria is you can recall the different properties of the rational exponent, and 2, you can use the properties of the rational exponents. All right, we'll start off with an exploration of the different properties of the rational exponent. So the property's name is going to be on one column, the example, and then the idea. So an idea here. What about if I have something like this? X times x plus x times x times x. Here, that plus here, you can't really do anything to it. So the x times x just becomes x squared. And the x times x is x cubed, which is here. A lot of students will try to add them together. You can't. And you try to call this the sum of the power. The sum of power is not true. There's no such thing as the sum of power. So don't do this. I only include this to tell you what not to do. But what happens when you have it as a dot? So here you have x times x times x times x times x times x, though, which is equivalent to x squared, because that's the first two x's, times, which is that red dot, x cubed. You saw that there's how many x's here? X to the 5. What you're essentially doing is just adding the exponent here. That's called the product of the powers. You can actually, if you have a dot here, which is the multiply, the product, you can do this. What about if you have an x squared times x squared times x squared times x squared? Okay, you're repeating the multiplication, and so in here it would be x squared, which is the regular number, but we saw that we multiply it 4 times repeatedly, so that's why the exponent here is 4. If you add all these together, 2 plus 2 plus 2 plus 2, you get 8. So essentially here you're multiplying. So this is called the power of a product, because that 4 in the power, it comes from this repeating 4 times. Negative exponent. You can't really find an idea about this. This is just something that we set as a fact. So you just have to memorize this one. If you have a negative exponent, you have to flip it. So x to the negative second power is the same thing as 1 divided by x to the second power. Or what about if the negative is on bottom? So in this case, it's 1 divided by x to the negative 1/3 power. That is just equal to x to the 3rd power. What about if you have a 0 exponent, like x to the 0? That's just equal to 1. Please note that x cannot be the number 0 in this case. What about if you have a division like this? So you have x times x times x times x times x, which is on top, and on bottom, x times x times x. Well, we know that here you should notice that x over x is just equal to 1. So we can start canceling out. This becomes a 1, this becomes a 1, this becomes a 1. It seems like we are just subtracting. So there's 5 x's on top, 3 x's on bottom, so you can just subtract that. That is called the quotient of the exponent. What about if you have x over y times x over y? Well, it's the same thing, right? This is just multiplied twice. So x parentheses x over y squared, the squared is going to be distributed to the top of the fraction as well as the bottom of the fraction. And we call that the power of the quotient. So these are all the different examples that you should see on how we came to this property. Right? Now let's go over the core concept. Okay, you should already have this from the previous slide. This time I just want to write it down in words for you to understand. The sum of the power. You cannot add two different exponents. You cannot add x squared plus x cubed. You cannot add those. Product of a power. You multiply of the same base. So here they're both x's. They're the same base. So what you're going to do is you're going to add the exponents. That's 2 plus 3 as the exponents. Product of a power. The exponent of an exponent. So do you see the exponent here is 4? And the exponent on the inside was 2. You will multiply the exponent. So 2 times 4 is 8. What happens if you have a negative exponent? Negative exponent, you flip the term. So x negative 2 becomes 1 over x over 2. If it's 1 divided by x to the negative 3, it just becomes x to the 3. So you just flip the term. And it becomes positive. 0 exponent is always equal to 1. So any number to the 0 power is just equal to 1. That's just the definition. Assuming x can never be 0. What about the quotient of the exponent? If you divide, which is that red, you see the divide symbol? Of the same base, they're both the same base, they're both x's. What you're going to do is you're going to subtract the exponent. So here, 5 divided by 3. What happens if you have a quotient here or a fraction here and you have an exponent? The exponent here applies to all the terms in the fraction, the top and the bottom. So the squared is going to be multiplied to the x on top, and the squared is going to be applied to the y, which is on bottom. You need to be able to write all these down and be able to recall it based on the given situation. So what you're going to do here is you're going to fill in the statement based on the correct property. So a to the negative 2, that equals to 1 divided by a to the 2. That is using the property of the negative exponent. What about ab to the 4th power? That 4 is going to be distributed to the a and distribute to the b. So it becomes a to the 4th power, b to the 4th power. This is the power of a power. What happens if it's 4 is the outside exponent and 3 is on the inside exponent? These two are going to come in and multiply. So that becomes a to the 12 because these two are going to multiply together. And this is called the power of a product. What happens if you're going to multiply a cubed times a to the 4th? These two is going to be 3. It's a3 plus a4. So you're going to add them, which is just a to the 7th. That is the product of power. That was the first one. A divided by b to the 3rd power. Recall that. Okay. The 3 is going to be distributed to the top and the bottom. So it's a cubed divided by b cubed. This is called the power of the quotient. A6 divided by a2. We saw that this is a division of the same base, so we subtract. So 6 subtract 2 is 4. So this becomes a to the 4. This is called the quotient of the power. Lastly, a to the 0, and we know any number to the 0 power is just equal to 1. We call that the 0 exponent. Next, let's look at some examples. You're going to use your properties of the exponents here. Use the properties of the rational exponent to simplify each expression. This is why you need to know this, because you're going to use all these properties here in this scenario. So number 1, a 2a cubed plus 2a squared. You can not do anything here. You cannot do anything here. Okay? This is already simplified. You cannot add them. What about now you can multiply them? 5a squared times 2a cubed. Well, 5 is going to be multiplied to the 2. And the a is going to be, the exponents are going to add together. So it's 2 plus 3. So here you get 2 times 5 is 10. And the exponent we add, so 2 plus 3 is 5. So the answer is 10a to the 5th power. What about you have a to the third to the fourth power? Well, here we saw that this is a power of a product, and we saw this in our core concept. The exponent of an exponent, we multiply the exponent. So here it's 3 times 4. So you get a to the 12th power. Number 4, 6a squared b negative 5. Well, that negative 5 exponent is really bad. So what are we going to do is we bring it was on top, now we bring it down. So it becomes 6a squared, which stays on top. On bottom, it just becomes b to the 5th power. Number 5, 7a 0. We already know that a to the 0 power is just equal to 1 because that is our 0 exponent. 7 times 1 is just equal to 7. 6, 4a to the 4th power divided by 2a squared. Well, we saw that 4 divided by 2 can just become 2. And we saw that the a to the 4th is on top and a to the squared is on bottom. That is the quotient of an exponent. So we're going to subtract the exponent. So 4 subtract 2 in terms of the exponent becomes a squared. So the final answer is 2a squared. Lastly, we have a divided by b to the 3rd power. We saw that the 3rd power can be distributed to the top, which becomes a cubed, and distributed to the bottom, which is just become b cubed. I wrote y here. This should be b cubed. Okay. So the first practice here is to use the properties of your rational exponents to simplify each expression. Give this a try. And again, you cannot do anything here. This is already can't not do anything here. Cannot do anything here. You can't add these two. Their exponents are different. The next one. Well, we saw that the 10 and the 2 can be multiplied together. And we saw that the x to the 4th times x to the negative 2, we add those two together because they have the same base. So 10 times 2 is 20. And 4 plus negative 2 is just 2. Number 4, 5x to the negative 2 and y to the negative 3. Well, number 3, I'm sorry. Number 3, 2a squared to the 3rd power. Well, we saw the 3rd power is going to be distributed to each one of the terms. So 2 to the 3rd power times, this should be a, I'm sorry. A to the 2 times 3rd. So 2 to the 3rd power is 8. And this should be a to the 6. Now number 4. 5x to the negative 2 and y to the negative 3. Well, we have to deal with the negative exponent. So we bring it down. So 5 stays on top. The x to the negative 2 becomes x to the 2, which is now on bottom. X to the negative 3 just becomes y to the 3 on bottom. Number 5. We saw it's pi times x to the 0 power, and we know x to the 0 power is just 1. So we can write pi times 1, which is just pi. Number 6. We saw 3x to the 5th power divided by 12x to the negative 2 power. We can do the division. 3 divided by 12. And we can do we could leave the x to the 5th power on top, but we have to bring the x to the negative 2 on top. So it becomes x to the 2nd power, right? We flip the exponent here because it's a negative. 3 divided by 12 is just 4, 1/4. And we saw on top x to the 5th and x to the 2, they add together, become x to the 7th, which is on top. Number 7. We saw that we have to distribute the negative 2 to both terms. So that's what I did here. I multiplied to the top and the bottom. But we saw that 2 times negative 2, which is x to the negative 4, and on bottom, it becomes y negative 4. We don't like the negative, so we flip them. So y negative 4 was on bottom. It went to the top to y to the 4th. X to the negative 4 was on top. Now it goes to the bottom as x to the 4. So these are your basic of using your properties of your exponents. Let's go to practice 2. These are more advanced problems. Be very careful. So the thing that you should notice is that these two can combine because they are by multiplication. So 4 times 5. And here you could add the exponents, 2 and 2. So you get 20 x to the 4th power. You have to leave the 2x cubed alone. Okay, you leave this alone. You leave this alone. You leave this alone. Right? Because this is to the 3rd power. You leave it alone. Nothing happens to it. Number 2. Okay. We distribute this inside here to become x to the 3rd power, and the 3 is the 3rd power distributes to the x. Same thing here. The 2 distributes to the 2, and the 2 gets distributed to the x. 3 squared becomes 9. X cubed, just x cubed. 2 squared becomes 4, and you have an x squared here. These two can still combine. 9 times x, and we can add the exponents. So 3 plus 2. So you get 36 from 9 times 4, and x to the third power plus 2 is x to the 5th power. Number 3. We saw the negative 5 as the exponent. So I'm going to distribute it into all the terms. To the 2 term, to the x squared term, and to the negative 1/3 term. So 2 to the negative 5th power, I leave alone so far. And I have x to the negative 10 because that's 2 times negative 5. And I have y, negative 2 times negative 5 is positive. Should this be a... oh, yeah, this should be a 3. Okay. Becomes 15. Positive 15. Okay. The y to the 15 stays on top because it's already positive. But these two are negative exponents, so they come down. So it's 2 to the 5th is on bottom, and y to the 10th is on bottom. If you want to simplify to the 5th power, that just becomes 32. Number 4. 10a to the negative 2 divided by 5b to the 0. Well, first of all, I split that apart. 10 over 5, which is on the outside. I brought the a negative 2 down, so it becomes a to the 2, as well as the b to the 0 power became 1 from our 0 exponents. So here I did 3 things at once. Okay, 10 divided by 5 just becomes 2, so that stays on top, and on bottom, which is just a squared. Notice, all I did here was I just applied all the different rules of the properties of the exponent. I didn't do anything differently. I just applied all these rules in a particular order. That's what you just have to develop. All right? So, but there you go. That's everything that you need to know how to do for the properties of the rational exponent, part 1.